Alright, let me go through the essential questions for the differentiation techniques, although it's a little bit overdue. So the first question, what does dy dx represent? Dy dx represent, firstly, the derivative of y with respect to x. Okay, WRT means with respect to x. Or in other words, is the gradient function of y, and hence the rate of change of y with respect to x. So as long as you see the word derivative, gradient, or rate of change, then it should suggest to you that you should be differentiating or rather applying differentiation techniques for the particular question when you see it in the exam. Okay. When do we write f prime and when do we write dy dx and when do we write d dx dot dot dot? Okay, you will use f prime x when the question given in fx form, and you will use dy dx when the question given in the y equals to expression form. Okay, if you are not given fx or y, then you can just straight away use the d dx of whatever expression is there. Okay, the 6 rules of differentiation, you have firstly the power rule, so power down, power minus 1. Then you also have the constant multiple rule. So basically, if you have any constant in front as a multiple of your expression, it will not participate in the differentiation. You can just take it out. Only all the x terms will be affected. The sum difference rule, the derivative of the sum is the sum of the derivative. Okay, so you can differentiate them separately and then add or subtract them back together. Chain rule, so dy dx can be written as dy du times du dx. This will come especially useful later in connected rate of change. But as of now, we will normally memorize it as the differentiate outside then inside rule. Okay, differentiate outside, multiply, differentiate inside. Then the product rule, d dx of uv is du dx times v plus dv dx times u, or normally we will teach it as differentiate left, keep right, plus differentiate right, keep left. Quotient rule, d dx of u over v will be v du dx minus u dv dx over v squared. Okay? Or you want to write it as differentiate top keep bottom minus differentiate bottom keep top over bottom square. So this is keep bottom, differentiate top, minus keep top, differentiate bottom, over bottom square. Next, in particular, if you have any kx and you want to differentiate it, it will just be k. If you have any constant you differentiate, it should just be 0. And you should link it back to that the gradient of y equals kx, which is actually just a straight line, is actually just k. Okay, remember the gradient of y equals mx plus c is m, and the gradient of y equals to k is always 0 because the horizontal line will always have a gradient of 0. Okay, for the differentiation, you just have 5 additional functions to memorize. Differentiate sine is cosine. Differentiate cosine is negative sine. Differentiate tangent is secant square. Differentiate ex is just ex. And differentiate ln x is just 1 over x. So if we have a particular example where it's not as simple, so let's say we want to differentiate e to the power fx, then using chain rule, it will just be e to the power fx because differentiate e is fx multiplied by differentiate fx, which is f prime x. Or let's say we have differentiate sine of fx, then by chain rule, differentiate sine is cosine, keep the fx, multiply by differentiate the inside is differentiate fx is f prime x. Alright? So for the typical questions, I want to go through one by one. I will just give you the answer here. So for the first question, you just differentiate them part by part. If you can individually differentiate, you individually differentiate. Right? So you'll get 4x cubed plus 6 because differentiate 7 is 0. For the second question here, x cubed minus 4x squared over 2x, this is put to remind you that you should not apply quotient rule blindly. Whenever you can simplify, you will simplify. Okay, so we will always try not to apply um, quotient rule unless it's absolutely necessary. So when you split them out, you will get half x squared minus 2x. When you differentiate, you will get x minus 2. 3x plus 8 power 5, apply your chain rule. So the outside is a 5. The power becomes 4. The inside is a 3. So your answer is 15 bracket 3x plus 8 power 4. X square root x plus 1, you need to apply product rule. So keep left. So I will rewrite this as power so that it's easier for you to see. So we keep left, differentiate right, plus keep right, differentiate left. To simplify, you will extract the common multiple, which in this case is half of x plus 1, power negative half. So you will be left with x. So I think there is, okay, the keep left here should be power half. Okay, so you will be left with x plus 2 bracket x plus 1, which means your final answer should be 3x plus 2 over 2 square root x plus 1. Okay, so if you're not confident of simplifying it, then you just don't simplify. Okay, you will just lose the presentation mark anyway. Okay, so d dx of 5x plus 7, x plus minus 2. For this, you can choose to apply product rule, or you can choose to expand. So let me, I choose to expand. So we will get 5x squared minus 3x minus 14. Then we differentiate this, so we'll get 10x minus 3. For 3 over x minus 2, you should not apply quotient rule also, okay, because apply quotient rule only when the numerator and denominator both have x and it's not possible to simplify it. For this, we can rewrite it as differentiating 3 bracket x minus 2 power negative 1. So you will get negative 3 bracket x minus 2 power negative 2 inside is 1 when you differentiate it. So your final answer is negative 3 over x minus 2 squared. Okay, so for the next one, x cubed over 2x plus 1, you have no choice. We need to apply quotient rule. So we'll apply quotient rule here. Keep bottom, differentiate top, minus keep top, differentiate bottom, over bottom square. Simplifying, you will get 4x cubed minus 3x squared over 2x plus 1 squared. This one is just the same as earlier, so I will not repeat this. Okay. For 4 square root x minus 3 over square root x square, you can choose to apply chain rule, or actually you can expand. So the answer will be about the same. So let's say I choose to expand. Okay, then we differentiate. So you'll get 16 minus 9 over x squared. Alright, for x cosine square 3x, it will be helpful if you write it as you recognize that cosine square 3x is actually cosine 3x whole thing square. So we apply quotient product rule. So differentiate, keep left, differentiate right. Then when you differentiate the cosine 3x, you need to apply chain rule, actually 2 times. Okay, so differentiate cosine is negative sign. Differentiate 3x is 3, right? And plus keep right, differentiate left. Okay, so go and simplify this yourself. For ln, although the formula is to flip it, but it will be helpful in this case to split it before you try to flip it. Because if you differentiate and flip it, then you need to apply quotient rule. Because when you differentiate x over x minus 2, you must apply quotient rule. So for ln in particular, you need to pay attention whether you can apply the special rules of logarithmic. So here we can apply the subtraction. So we can write it as ln x minus 2, which will make your life much easier when you differentiate. So you just get 1 over x minus 1 over x minus 2. So this is important. Okay. Next, product rule again. So we're going to keep left, differentiate right. But because you differentiate 5 minus 4x, we will just flip it. You need to times negative 4 due to the minus 4x. Plus keep right, differentiate left. So when you differentiate left, you get e half x but times half because of the half x. Okay. Then you're going to simplify this by factorizing the e to the power half x and a half out. Okay. So next one, same thing. Don't go and blindly apply 1 over and then product rule here. We will split this by using it as a sum. And once again, you can simplify it further by writing it as half ln of x squared plus 1. So you get 1 over x plus half. Ln will flip it. Inside will be 2x. Okay. So you get 1 over x plus x over x squared plus 1. Alright. Okay, I will give you some idea of why the sum rule and the product rule works in such. So let's say we want to differentiate fx plus gx. Okay, you can see as is just finding the rate of change of a bar called fx and a bar called gx. When you add them up, the total is fx plus gx. So the bar has 2 parts, a part called fx and a part called gx. So if fx is increasing or changing at a rate of f prime x, and gx is also changing at a rate of g prime x, then the whole bar must be changing at a rate of f prime x plus g prime x. Okay, so the rate of change of the sum is just the sum of the rate of change. Okay, how do we understand why product rule is so restrictive? Okay, the question that many of you should be asking is why is it thus not equals to g prime x times f prime x? Okay, that's very ugly. Okay, so just think of it, same thing. We are going to use the geometry to help us. So we have a rectangle. Okay, if let's say this side is f prime x, this side is g prime x. Sorry, gx and fx. So both sides are increasing. If fx increased by f prime x, so the rate of change is f prime x. So let's take it as we increase by f prime x. So we increase by f prime x. There is a slightly in a small increment called f prime x, and gx side increased by um, g prime x. Okay, so your new rectangle will be as such. Let's put it in orange. Okay, so when we take f prime times when we take fx times gx, you should realize that in terms of my analogy, fx times gx is the area of this rectangle. So can you see that when I want to find so this is area of rectangle, and remember d dx is to find the rate of change. We want to find the rate of change in the area, so we want to find the change in the area. I hope all of you can see that the change in the area here from the original rectangle to the new rectangle with the increase in fx side and gx side is this shaded part. This L-shaped region is the change in the rectangle. So remember, we are now finding the change, okay, because d dx is to find the change. The change is the L shape. So what is f prime x times g prime x? See that this is fx, as f prime x, and this is g prime x. When you multiply the two of them together, all you get is actually this part. Because if I write it explicitly here, this is fx, f prime x, and this is g prime x. So when you multiply, you just get that. So clearly, the red shaded part is not equal to the L shape. The L shape cannot be equal to that. Okay. On the other hand, if we break it down and I write down the original correct product rule, d dx of fx gx is actually fx g prime x plus f prime x gx. So the first part, fx g prime x, actually is this part here, because you have fx here multiplied by g prime x here. So this is fx g prime x. And the second part, f prime x gx, is actually here, because this is actually gx, and this is f prime x. Okay, so clearly, the two longer pieces of rectangle is more similar in area to the L shape than the red shaded part. So why can we ignore the red shaded part is because for the consideration of f prime and g prime, remember, they are absolutely very small. They are so small that we can ignore them. But that cannot be said about f prime, fx and gx. When fx times f prime, g prime, and gx times f prime, they may not be significantly small. Okay. So last part, I want to talk about how can we cheat using differentiation when calculating gradient for E-math and especially A-math. If you have absolutely no idea why when we differentiate these functions here, you get that. Okay. Then recall that the fundamentals of differentiation is that when you have a curve, you have an original point called P, then you can always find the gradient at P, which is given by this tangent. Okay, so this gradient has a certain correct value. What do we do is you can choose a further point on the curve called Q and find this gradient here. Okay, and see that the red line and the tangent can be similar if we move Q towards P. So for example, let's say I want to do it for EX. Then what I can do is X value, EX value. Okay, so this is what I would normally recommend you to do. Okay, maybe not this. Let's say we do X squared. Okay, So let's say I want x and my y equals to x squared. Okay. Then you can set -2, -1, 0, 1, 2. Then the y value you will get 4, 1, 0, 1, 4, right? Okay. So what you will do is you will cheat now the dy dx value. I will demonstrate one time for you. So let's say I want to find the dx value at 2, right? X equals to 2, 1. What you will do is you will choose a value to the right of your current x value. So 2 is my current x value. A value to the right will be, let's say, 2.0001. You must choose a value that is close. 2.1 is not close enough, right? 2.001 is better. So my gradient is always y1 minus y2 over x1 minus x2. In this case, is y of q minus y of p over x of q minus x of p, where p is these x values here. Okay, so q will be that point towards the right. So we can now sub 2.0001. Y is x squared minus 2 squared, which is 4, over 2.001 minus 2. Okay, when you do this, you will realize that you should get a number that is close to 4, which is something that you can repeat. Then you repeat for all the other previous values and you try to observe a pattern. So if we now have an EMAF question, let's say y equals to 3 over x plus x squared. And let's say you don't want to use differentiation for some reason, or you forget to differentiate. Then what you can do to find the tangents gradient, let's say at x equals to 3, the gradient should be approximately equals to 3 over 3.0001 plus 3.0001 square, okay, minus the original x value, which is 3 here, so 3 over 3 plus 3 square over 3.001 minus 3. So use this calculated answer to check whether the tangent that you have drawn, the gradient, tallies with this by not too much. Your difference should not be too much. If your difference is too much, means your tangent, you need to either adjust it to be gentler or steeper.